Hi, and welcome to the ZP Food Sense webinar. So we do these webinars, one in the morning and one in the afternoon once a month. When I say afternoon, this is kind of London time, even though I have some colleagues joining me from Norway today. So the Food Sense webinar really is just a demonstration of the Food Sense technology. So don't let me, I won't spend so much time talking, and I'll essentially dive straight into it. So if somebody's a Food Sense client, i.e. they've bought the technology, everyone gets personal online training. So online training is, we have obviously laboratories and Food Sense technologies at our place. We'll do online training with people, make sure that they're comfortable so that they can get going it directly. We do weekly webinars. So for example, every Wednesday at 8 a.m. London time, we do a weekly webinar. And so this week, we just had some questions coming in from somebody who's using the technology, and I've logged their questions, and their questions will be answered in that webinar. We also do these monthly webinars as well. So what I mean by a monthly webinar is, we will do these live streaming demonstrations of the Food Sense technology, and that's what we're going to. So I'll do a bit of a technical introduction, and then we'll dive a bit more into it. Just to say, when I say monthly webinars, we do have another webinar on the 14th of December. I know it's a little bit close to the Christmas period, or the holiday period, if I can call it that, but we do have these monthly webinars. So there is another one as well. And just to say that, this, so if you want to see this again, you can attend that. Just a quick introduction to ZP. ZP was launched in 2014. The Food Sense technology that we're discussing today is almost as old as the company. It was one of the first things we started doing. We are what's called ISO 13485. So a lot of what we do at ZP is the contract development and contract manufacturing of really biosensors and medical diagnostics for people's health. That's what we're qualified to do. So it's sort of an easier thing to measure chilli or capsaicin rather than to detect diseases like SARS-CoV-2, etc. So we do a lot of contract development and manufacturing of biosensors. Our facilities are not super huge. They're also not super small. And we are in more than one country. We're at least in Norway and the UK. The team is large, international, as you can suspect. People from, Portugal, India, Spain, USA, South America, China, Bangladesh, all across Europe as well, of course. And we do have multiple sites. Our sites are really sort of state-of-the-art facilities. What I mean by that is it's the kind of facilities that you would find for manufacturing electronics and semiconductors. So we do have these multiple facilities, a large manufacturing area, R&D area, and then we have two smaller facilities also in the UK as well. So on October the 16th, we went live with our G4 product. So this is, literally, there was definitely generation 0, a generation 1, a generation 2, a generation 3, and now we're on generation 4 of Food Sense. And you can see that this is a kind of generation 4 product just by the sort of maturity in it. It's smaller. It's definitely easy to use, and we'll run through that today. It's more accurate. We have learned a lot of lessons over the years. It's what's called cloud enabled. This is an important aspect because what you'll hopefully see today is that the data goes into the cloud, which you then have access to. And this means that if there's any concern that, because it's often with technology, you'll get a number, but how do you know that that number is true? Well, we can actually see the raw signal behind that number. So we will definitely be able to demonstrate that. So what's quite nice about the product as well, it's got LEDs on it, and these LEDs actually tell you about the status of the instrument. So when the instrument is not in Bluetooth connection with the app, it's a flashing blue light. When it makes Bluetooth connection with the app, it's a solid blue light. When it's running the assay and when it's completed the assay, it goes green. And when it's uploaded, the data, it goes green. And it can do more than one analyte at a time. As I say, this is kind of, I'll just run through this fairly quickly, but the nice thing about this video is you can see that this, there's a strong team actually behind this. You'll meet Solrun today. I just noticed that Solrun there is actually looking at essentially the raw signal from this instrument. I can see it on her laptop there, but the user experience is they don't get a raw signal. What's quite nice about this instrument is just simple things like, once upon a time, sensors had to be slotted in this little slot, but now actually they're just placed on the sensor and we just click it up and it all engages and makes a nice electrical connection. You'll see it done today that we make a 50 microliter sample onto the sensor. And you'll see that it's actually app driven. There's an app on, for example, on the Android Play Store. And it's just really QR code. So a QR code tells the app what to do. And then, for example, in that case, Guyana had scanned the Ginger app and we were running Ginger. We've got a strong electronics group and a nice product design team as well. So there's a lot of, this is a very mature product at this stage. I did mention it, but you'll see it happen today that we use, we use QR codes to help us go between different assays. The assays that are available today are Ginger and chilli. So the chilli is measuring Scoville heat units and the ginger is measuring the gingerol in the product. As I say, ginger will also, this is Solrun in our lab testing on a generation 3 product, but this is just to say that we do ginger. What you'll notice today about these about the technology is also the speed of the assays. One of the things I should have said is, since G3 to G4, the whole technology has got a lot faster. And let's be frank, I mean, the current kind of workflow is that most of the time, people are not testing. In fact, it may go off for HPLC testing, but that might be a real may go off to HPLC testing. So if you want to, we'd also ask if people are interested in adding to this. So what I mean by that is at the moment, we've got chili and ginger. We would like to hear from people. If there's kind of something else that they would like to test, we would definitely like to hear. And we do have a link here, which will allow people to ask for extra analytes. So I'm not gonna say what I think you may want us to test. I'd rather just hear what you want us to test. So you can ask us to expand the menu as well. This is a patented technology that we licensed from the University of Oxford. They really just sort of did the proof of principle. Today, when you're watching the demo, you'll see something called you'll see the progress bar. The progress bar will go around. What it's doing is, and this is patented, and this is why I can talk about it, it's doing a technique called voltametry. It will literally give us a fingerprint of the molecule capsaicin, and then it's the intensity or the areas under the curve that tell us how much capsaicin is in there. This is really important to you because people talk about HPLC, high pressure liquid chromatography, but they very rarely get what's called the chromatogram, and they very rarely get the calibration routine. All they get is a number on a certificate. They say, oh, well, there you are, there's the truth. Well, you've got very little evidence of the truth other than it's a leap of faith that actually is correct. So if you want to measure the Scoville heat units of chili today or the amount of gingerol and ginger today, it's HPLC. Some people do panel testing, but very rarely. I think most of the work is actually guessing. People are just guessing. There's no, and then there's actually food sensors. I should change that to generation 4 products because it is now generation 4. See, food sense is not subjective. When you taste something, the subject or the person doing the testing is part of the test, so it's subjective. Objective just means that there's not a human being involved in that measurement. Admittedly, we see the result and we put the sample on there, but we're not the ones tasting it and making a subjective determination of the hotness. No, it's an objective determination. Something that people are very keen on is how do we know that it works? Well, we will get the raw signal, so we will literally see the fingerprint for capsaicin, and we don't on the app itself, it just gives you the number, but we actually get the raw signal, so we can see that it's the right shape that tells us it's capsaicin and the area under the curve. But we've also tested obviously against HPLC. We have a Waters HPLC instrument. We are able to run the AOAC methods in-house. So we made sure that we could kind of correlate with those with the HPLC method. We also, and this was independent of us, we got a unit was purchased by the University of Minnesota, where a guy called Charlie Rower purchased it. He did his own independent studies. He wrote a scientific paper on this, and he really gave it a very, glowing reference, because I think the things that impressed him were it does what it says. It's a very rapid test. It's a low-cost test. He compared against HPLC and found a good correlation. I think he was very happy with it. And what he found out was that he was able to test every sample in triplicate on the food sense because it was low cost, fast, and he could just do it himself. With HPLC, he could only send one sample off to the lab because he couldn't afford to do any more, because it was, in the US, I think it's like $100 per test. It may be lower in other parts of the world, but it's still expensive. And that's why people are simply not doing it. The thing about HPLC is if you send the same sample to three different labs, each lab will give you a certificate of analysis, but none of those results will be the same. It's statistically impossible for them to give you the same results. So in fact, HPLC, the standard, let's say, is not it's not super precise, because in fact 3 labs will give you 3 different results. If you send the same sample to the same lab but give them different sample IDs so that the lab doesn't appreciate, they're sort of blinded, they don't realize that you're actually giving them the same sample, you will get 3 certificates of analysis. They'll all have different results. So be careful. We do get this request, what's your accuracy? And my response is accuracy against what? Because actually there is no, what they think is accurate or precise even is not actually accurate or precise. Now at ZP, you'll notice one of the things that we do today is, depending on the hotness of the sample, we change the volume of the buffer. So if we think it's mild, if we think the sample is mild, we'll do what's called a 1 in 10 dilution. If we think it's hot, we'll do a 1 in 100 dilution. And this is because capsaicin is the nice thing about the buffers that we use is, if you're dealing with HPLC, you're dealing with organic solvents. It could be methanol, it can be acetonitrile, both of which are toxic. So you not only use them, but you then have to dispose of them. The nice thing about the buffer that we ship with the food sense is it's inert, or it's safe. You don't drink it, but if you did drink it, it would do you no harm, but don't drink it. But the reason I bring this up is because capsaicin is not terribly soluble in waters or liquids. It's okay in organic solvents. It's quite an organic molecule, but it's not terribly soluble in liquids. So it's got a solubility of approximately 480 Scoville heat units. Of course, I understand that when people are making chili sauces or chili products, their Scoville heat unit is much higher than this. And it's because of the oils and the fats that they're putting into those products are actually solubilizing the capsaicin, but intrinsically it's not very soluble in water. So that means that we have this kind of rough idea that it's about 500 Scoville heat units is the maximum solubility in the buffer. So let me ask you a question, or a question that you would ask your users. What do you think the hotness of your product is? And if somebody says to us, oh, it's between 0 and 5,000 Scoville heat units. 5,000 Scoville heat units is not terribly hot. It's about the hotness of neat Tabasco sauce. But if that was their answer, we would say do a 1 in 10 dilution. If they said, oh no, this is a chili powder, it's more like 50,000 Scoville heat units, then I'd say do a 1 in 100 dilution. What you can see here is that if it's 50,000, if I divide 50,000 by 100, I get 500. If I divide 5,000 by 10, I get 500. If it's a really hot product, we have had these, there's something called the bomb out there, which is a very hot chili sauce. It's about 125,000 Scoville heat units. But if it's very hot, like 500,000 Scoville heat units, we'll say do a 1 in 1,000 dilution. If you take 500,000 divided by 1,000, you'll get to 500. So we're just making sure that we're not, because we can get really precise results, but it could be through saturation. So that's why we ask the question. And if it's really hot, I just heard the other day that the gentleman who breeds these really hot chilies has just made one that's like 1.3 million Scoville heat units. Well, in that case, we would do a 1 in 10,000 dilution. If you get stuck or your customers get stuck, don't worry. We're very scientific, very geeky at ZP. We can answer questions and we get online and help people out. This is actually customer data. It's only about 3 or 4 weeks old. Somebody got a food sense product off us and they tested it by HPLC. And they also tested the same samples by food sense as well. So sample 1, sample 2, so they did it to, a really good, analysis. And actually let's say the errors on one of the samples, it was 5%, on another one it was 4%, on another one it's 3%. Now, I think we're the truthful. Like here, I haven't said who was in error. Is it the HPLC or the food sense? The only thing I could say about food sense generation 4 is we have the raw signal, so we can back up our statement. Whereas this person will only have a certificate of analysis from the HPLC place. The average of all those errors was 0%, by the way. Now I'm going to do a demo. So what I'm going to do is I'm going to stop sharing. I'll turn off my screen. I'll turn on my microphone, and my colleagues, Solran, who will be directing, and Georgie will sort of kick in. So I will do that.
Hi, so my name is Solran. I'm a scientist here at Simran Peacock, and today I also have my colleague Georgie, which will present the device to you.
Hi, you guys. Yeah. Can you hear me?
Yeah, we can hear you all right. So yeah. Let's see the device, Georgie.
Yeah, let's start just having a look at the physical device. I'll switch to the top camera. So here we go. This is the device itself. As Martin has said, we have redesigned the connector, so now it's much simpler to insert the sensor. It's actually, well, this is why the shape is like this, because it has this moving part that allows you to just insert the cartridge and then you lock it and it locks perfectly every time. The cool thing about it, if you actually spill the solution inside, or if you need just clean the device before you go to the lab, or you need to, maybe something happened, you need to like fix the internal parts, you can remove the moving part and actually clean it from the inside. And maybe just put this moving part into the solution so it will also clean. Yeah, so this is how it looks like, and let's just start it. And it starts with a button and it's ready to use. So when the green light is turned on, we can use the device straight away. Yeah.
Okay, I will show quickly how to prepare samples, because preparing samples is a crucial step of the testing itself. So today I have some chilies here. I got some sauce, Tabasco sauce, and also powders, because all those three can be tested with our device. Usually, if you want to test a chili, you would like to chop it up into as small dices as possible, just so that it's quicker to extract the capsaicin, the pungent molecule of chilies, into the solution. And we will dilute it in what we call the chili pop buffer. So the CP chili pop buffer is an electrolyte, and it also reduces the number of variables, in the sense that when you dilute your sample in this, you will have the same environment for all of your samples, and therefore you will not have as many variables as you would if you would just test the sample itself. So for a sample like Tabasco, which is not that spicy, we will be using a 1:10 ratio. And Martin, he does have these presentations on how to dilute your sample and how to determine which pungency and therefore which ratio to dilution ratio to use. But let's just do a quick sample preparation of the Tabasco sauce. as it is easy to show. So I will just pour some Tabasco sauce into a beaker like that, just so that's easier to pipette it. And then I will prepare a 1 to 10 ratio. So 9 parts of the chili pot buffer and 1 part of the Tabasco sauce. So what I will do today, I will be using a weight, a kitchen scale. And then I will add, so I have a vial like this one, and I will add 1 part of the chili pot buffer, or 0.1 milliliter. And I can also do it based on grams, so I could add 0.1 grams. And then I will add 0.9 milliliters or 0.9 grams of the buffer. So like that, and then look at the weights, and there I have a milliliter. All right. And the advantage with Tabasco is that it's a very liquid solution, so it's fairly easy to mix. So usually I would be in the lab, and there I would use a vortex just to cheat. But if I'm on a restaurant or some other place, that might not be possible. But for Tabasco, it's a very liquid solution, so it's quick to mix into a homogeneous solution. But if you have, let's say, the chopped up chilies, it's less homogeneous and it needs more time to extract. So sometimes I would even let it rest on the bench for a few hours or even overnight, and then I will test the day after. And it has to do with the solubility of capsaicin, which Martin was talking about. So then we will go back to Georgie, which will show the already prepared samples and test a fairly not too spicy chili sauce with the Generation 4.
Okay, so we have the prepared solution that Solheim has prepared, not the identical one. It's has been prepared a little bit before. So we have this mild chili sauce mixed with buffer, and it had been here for about a day. So what we do now, first of all, we need to run an app, and I will turn on the screen where we will have the app as well. So I
Georgie,
have it here in my my hand, the app. So first of all, what we're going to do, we will want to connect the device. So we
can you move the app a bit further to the right
center
on the screen? Yeah, because Teams cuts off your screen, so your screen looks square. Perfect. There we go. Yeah.
All right. So I'll stay here. Okay. So we connect the device, right? So we press the button, wait until the green light is on, and then we go to the app. We press the button, connect the device. And
Solheim, if you turn off your camera, it might give Georgie a bit more space as well.
Oh, we have frozen.
It's fine, Georgie.
Do you
go
see
ahead.
the changes in my screen?
Yeah, everything's fine. Yeah, don't worry. Go ahead.
Okay, so when I press the button, okay, so let's just switch to another camera. I think it's actually not showing. So let's just do it like this. What we do, we turn on the device, press and hold for 2 seconds, and then the light is on. We go in the phone, and then we press connect the device button, and we see the device straight away. Wait a little bit, then it's connected. Perfect. Then what we do now, we want to select the sensor. It's already set to chili sensor, but depends on what kind of sensor we have. We can press this button, and then we scan the QR code for specific group of sensors. For instance, we want chili sensors, we want ginger sensors, and then this QR code also contains some information about the sensor batch So all the settings are adjusted in the background. So we now scan the QR code for chilli sensor, and then we go to test settings. What we write here in test settings, we write the sample ID, and the sample, we can leave it my test, plus the name, we can call it demo for now, and the operator is me, which is George. Cool, let's leave it this way. And then we go to assay, and we select the dilution factor, and yeah, so I think we go to 1/200 dilution factor. So
Is that
we
right,
have.
Solron? Was it 1 in 100, Solron?
Is it right, Solron? Yeah. Can you double check me here?
Yeah, I think you actually picked one of the ones that were more spicy. So those were actually prepared 1/200. So you have a bit more pungent chili sauce. So it's good. Let's go with 1/200.
All right. So we have. Now we take the device. Okay, let's just place it here so it's visible. We take a sensor. We lock it into the device. Then we take the sample and take 50 microliters of the sample. Oh, we need a pipette tip. Sorry, I almost touched it. First of all, we okay. We take 50 microliters, pipette it on the sensor. And we press start measurement on the app. Then we wait for approximately 30 seconds.
So this is that cyclic voltametry part that we said is sort of, it's patented technology from Oxford University, and that progress bar, we're not we're not trying to give people a scientific experience. We're trying to give them a nice, simple user experience. But secretly, that in the background, that's what it's actually doing. It's doing essentially a scientific measurement. And what do we get then, Georgie?
Okay, check network. Okay, yeah, everything's good. So we have the results on the screen.
Cool. So
and
that's
the
a
upload is
result
complete.
of...
So what can we do now?
Yeah.
We can actually go to our Julie account and then see it from the cloud. And I'll just switch to the screen with Julie.
So this is the point that we were making earlier on, that not only do we get a result on the app, we actually get the raw signal in the cloud. So this is the bit that leaves, when people are asking what's your accuracy or something like that, we can actually genuinely see the raw signal for this. So love to see it, Georgie.
Yeah, so we go to our cluster name. We find cluster name called demo, which we just called. And then we go to the last.
Yeah, this device is called 4C.
Let me just refresh the page. And
I think the device is called 4C apparently. Is that correct, Solron?
Yeah, it's the third device there.
Yeah, okay. We go to the third one. And so we called it my test, I think.
Yes, it's the one at the top there. That's right.
Yeah. Okay. And now we can see the report for this test.
There we are. Perfect. Yeah, very nice.
We can see the raw data, the voltammogram. We can see all the peak heights, everything. So it's all stored in this page in Julie, which is relevant to this test. We also have all the data, all the operators, and all the IDs straight.
Exactly. So it can be part of somebody's quality system. So just out of interest, Georgie, what was the Scoville heat unit measurement? It looked about 65,000, but I couldn't quite see it on the app. But just tell me on the app what it said.
Yeah, it's 65,000 SHU. Yeah,
65,000. Okay, cool. Are you able to do a ginger demo today?
Yeah, we can try that. We can try to do that.
Great.
So I'll just demonstrate how we can switch. Okay, I'll go to the top camera one more time, and I'll just show you how we switch from one sensor to another. So we remove the chilli sensor, and then we press scan the sensor. Oh, it automatically did it, but let's do it one more time. Actually,
So
very
quick,
fast.
yeah.
So it's the lightning speed. So let's do it just, yeah. So we pointed to the ginger sensor, so we have it basically, yeah. The same thing, we can call it sample ID, we can call it my test ginger. And the operator ID is George. Everything, we can leave the same cluster name is demo. So I think it's good. Okay, so now we have a ginger sample. It's and ginger sensors here. So we put the phone here and lock in the sensor in place. Then we take a ginger sample.
Just pull the hardware slightly into
diluted.
shot, Georgie. Just pull the hardware slightly into shot. That's okay.
Okay, hardware in the shot.
Yeah,
okay,
perfect.
Cool.
Thank you.
Yeah, and then we take 50 microliters.
This ginger sample, while Georgie pipettes onto the sensor, this ginger sample is prepared by a ginger shot, so it's a 1:10 ratio. 1:10 ratio dilution with a ginger pot buffer, a ginger buffer, the CP ginger buffer, and so 9 parts of the ginger buffer and 1 part of the ginger shot. And that's how the sample was prepared.
Okay, so the dilution factor is 10. Yeah, right. And we press start measurement and wait for the meter to make its magic.
As you maybe noticed, Georgie disposed of the sensor that he tested for chillies, and you have to do that every time you use these sensors because these are one-time use sensors, and the reason for that is because the capsaicin and the ginger is very fond of the surface of the sensors. So if you would test them several times, it will be higher and higher results every time. Yeah.
So okay, here we have the results, and again we can just quickly go to Julie and just see them where they are stored.
Just out of interest, what was I know it's in something like milligrams per something, but what was the result?
It's 800 milligrams per liter.
Per 800 milligrams per liter, is that correct?
Yeah.
All right, so that's 800. That's
so,
800 parts.
You can see it here. It's here's the result.
All right, so 800 parts per million. Okay, that's perfect. Thanks very much. But yeah, love to see Julie now. So we went up to Julie, did it?
Yeah. Okay. So we update the page. Okay, and we go my test ginger, and we have all the data on this test in Julie. We
Perfect.
see voltamogram, we see peak heights, and so yeah, basically everything is here.
You might think that the curves look fairly similar between the capsaicin and the ginger, but we do apply different settings. It is in a different range, so the curves are quite different from one another. So
Great.
that's why
So let
we
me,
need to scan the QR codes. Yeah.
Let me because I unfortunately I know you guys have got a few we've got a few meetings, so we'll probably have to do a sort of a wrap up. But I think what we've demonstrated today is so this is generation 4. You know, so this product is several years old now. It's it's come to a really nice state. We have really nice little hardware, the way it's kind of clicks together and the way the app actually runs it. The user never has to go to Julie, but so they'll get a result on their phone. They can make a note of it, and they're good to go. But just so you know that actually we do get the raw signal. So one day, if there's ever a kind of a problem, either because some supplier has argued, or the supermarket has argued that the product was hotter or more pungent than normal, we can go back to the raw data and actually really give some evidence of this. And that's different from other systems where you don't have the raw data. You have a certificate with a stamp on it and maybe a signature, but that's a limited amount of evidence. But we actually get the raw signal itself. And as you saw, we tested today ginger and chili sauce. And it's probably worth saying that if you've got any questions, don't hesitate to reach out to us. And we'll do again another webinar on the 14th of December as well. And any questions that come in during the week, we do a webinar every Wednesday, which is just questions and answers. So I want to thank our guests this morning for coming, and thank you for Solron and Georgie for a lovely demonstration. Especially Solron, who's busy traveling at the moment. So thanks very much, guys. Bye-bye.